We're going to go fast in this session, if that's okay. You might think I speak too fast. I apologize. It's because I'm kind of hyperactive, and I did have coffee this morning. So while I've not slept much all week, I've had some coffee. I'm ready to rock. This is my 8th session of the week. Basically, we had 3 with GIDS. This is the third one for GIDS. But the Red Hat team had me go speak at WePro, had me go speak at Infosys. I did the Docker meetup with Arun Gupta last night. If you missed out if you didn't come to the Docker meetup last night here in Bangalore. It was a good deal. So we did some really nice stuff there. And there's actually some really good demonstrations and part of that content you would love to see, but we're not going to have time to touch on it here. But we are going to focus on Docker very briefly, Kubernetes, a chunk of that, but I want to take you down the path to where we're going with these technologies. So you probably don't know, but Red Hat is the second largest contributor to Docker outside of Docker, and we're the second largest contributor to Kubernetes outside of Google. And so we participate in these projects very, very heavily, and we're constantly looking for new ways to make them more useful, more usable, more developer-friendly, and the Fabric8 project is kind of the tip of the spear where we do this experimentation. Now, you can go to the Fabric8 website, and you're probably thinking, oh, let me try the getting started experience. I can tell you at this moment it is not working, okay? So it's an R&D project, if you will, and sometimes when you're doing a lot of R&D, things break. And so things are kind of broken right now. But I'll show you what I have working on my laptop to just give you a feel for where this project's going. And again, everything we're talking about here is free and open source, and we want you to get involved. So the Fabric8 project is an awesome place for you to get involved if you wish to become an open source contributor, because it's a relatively small team, relatively new project, and its primary purpose is to glue together Docker, Kubernetes, things like Jenkins, and a bunch of other stuff that I'll show you, okay? So it's really where we're bringing the DevOps experience, continuous integration and continuous delivery to container-based development for microservices on top of those platforms. So hopefully you'll see some stuff you like, and then, but like I said, we'll move quickly here. I've been told, this is Bengaluru, is that right? Awesome. My designer gave it to me. But I'm super excited to be here in India in general. I love coming to India because the folks here are so hungry for information. I enjoyed the conversations, the Q&A. Oftentimes you guys are very, very challenging, asking me hard questions that I don't know the answers to, but that makes me better. It makes me better as a presenter, makes me better as a software engineer, and I feel it makes me better as a person. So I really appreciate coming and spending time with you on a regular basis. But really, you guys are the hero of this story, so keep that in mind. If it wasn't for the work that you do on a regular basis, we wouldn't have information technology to run the globe that it does now. It doesn't matter if it's a startup or a big bank or an old enterprise, a manufacturing company. You guys are making the magic happen on a regular basis, and at Red Hat, and doing everything through open source that we do, we're trying to further enable and further energize you to help you do those things. That is just our purpose. And you're probably thinking, well, how do you guys do everything open source? Exactly. We do it that way because we know it helps you. It makes you better, and you help us become better accordingly. But let's keep jamming along here, okay? Do go to developers.redhat.com for more information about the various things I'll touch on. Also, Fabric8.io. You'll see that a little bit later on, too. So continuous improvement is better than delayed perfection. I don't know if you know Mark Twain, very famous author from the US standpoint, but if you can continuously improve incrementally, right, it's taking small increments to continuously improve, it's way better than being perfect, okay? That's kind of the point of this. And so we're going to be focusing on that, and that is the ultimate goal you'll find in our Fabric8 project. I do love using my evolutionary slides, or if you saw my flying elephants earlier on Wednesday, I love the concept of how we are all on this journey to become better. And so DevOps is super critical, and this is a platform and technology to help you enable DevOps for your organization. I do believe fundamentally in cloud self-service infrastructure. Again, you should not be waiting 3 weeks for a virtual machine. You cost too much, okay? And at one insurance company, it was 6 weeks. And all the people there wait 6 weeks to get a virtual machine. You cost too much to wait 6 weeks for a resource. So you should have some form of self-service on-demand infrastructure, right? Think in terms of automation. Everything should be automated all the time, every time. Doesn't matter how you bake out your servers, and whether it be virtual machines, raw hardware, AMIs on Amazon, I don't care how you do it, or containers like I'll show you here, you should fully automate that as much as possible, okay? Automated pipelines are super critical, and most people actually do not do CI well yet, but you're going to continue to grow in that category as we all are. Even at Red Hat, we still struggle with this. At Red Hat, we often use traditional waterfall processes to produce the products that we produce. And you might be thinking, what? That's crazy. But Red Hat is a 20-plus-year-old company too. So guess what you did 20 years ago? There wasn't this agile stuff and all that, and DevOps. No, we did it the traditional way by passing the buck from team to team, and someone would do their 6 months of work, and the next team would do their 6 months of work, and the next team would do their 6 months of work. We have a lot of teams within Red Hat that still do it that same way. So we're still learning along this process. We won't get a chance to spend too much time on deployment techniques, but hopefully you saw Rafael on my team, Rafael Benavides. He showed you some really awesome examples of blue-green deployments or canary deployments and all that in his presentation, and we did it last night at the Docker meetup. We're not going to get a chance to do that here because we're going to move too fast. Okay? I fundamentally love the movement in the Java universe. The Java universe has seen so much tremendous innovation of late, with things like, Drop Wizard, which came out with this concept of the fat jar. You pack all your application inside a jar file and ship a single jar file. Then we saw that happen with Spring Boot. We saw it happen with VirtX, right? VirtX adopted the fat jar concept around the same time as Drop Wizard. Spring Boot happened, putting Tomcat in your fat jar file. And we also have Wildfly Swarm for Java EE programmers. So at this point, it's almost just an issue of what annotations do you like, right? You can do this with Java EE annotations, Spring MVC annotations, or you can do it with a reactive programming model in VirtX. If you saw my VirtX session, you saw a lot of that already. So there's just a lot of awesome stuff here, but this is the payload the Java developer wants to move through their pipeline, okay? So we'll show you some of this when we get going. Let's move a little more quickly, but again, waterfall was the old way. We're migrating from Agile into DevOps from a methodology standpoint, monolithic architectures to n-tier architectures, SOA back in the day, to microservices architectures going forward, physical servers to virtual servers to containers, Linux containers being ultra lightweight, and of course, regular old data centers. And here's what I love about old data centers. Did you guys ever have that little server sitting beside your cubicle? You know what I mean? And you had everything you needed there, and that was a production server. I did this, okay? That was the data center. Well, we don't do that anymore. We now have these nice little slim rack-mounted servers all packed up into a nice rack in a beautiful data center. It's clean, with nice air conditioning. No, some of you still have some servers sitting beside your desk, I know, or underneath the desk. This happened to me at Red Hat, okay? One person I worked with, we were running a production system on a system like that, and it was specifically for running webinars at Red Hat when I got there. We had 600 users live on the system, and he kicked the power plug out the back of the server. Okay? So this stuff happens, all right? And you mature, and eventually you get to, hosted models and cloud models. Okay? So DevOps, microservices, containers, and clouds all are related to each other. I fundamentally believe you get the synergy and the benefit when you pull it all together and make it work for you. And that's what we're focused on here today. You got to think in terms of continuous assessment. It's not just continuous integration and ongoing automated testing. People are starting to do that better now, all right? We're doing better stuff in that category. And we're learning about continuous delivery, producing an immutable artifact like a Linux container or Docker image that moves through our pipeline and eventually may be able to deploy in production. But we're also starting to look in terms of continuous operations. How do we do great and brilliant monitoring of our environment to know what is behaving well versus not behaving well? And I'm going to make the argument that the developer should be involved in all of these steps, specifically this one over here. You really want to be able to see your software run. You want to know how it behaves. You want to know if it's using too much memory, too much CPU, the business is performing better or worse based on the changes that you make. And that's part of the DevOps movement, really owning that piece of the application as well, meaning the runtime, the production side of it. Okay? Now, if this is what software feels like to you, I used this before, but I love this image. I worked really hard with my designer to come up with this idea. But if you do have the amorphous blob where you're not exactly sure what the big old thing is, and you got a whole bunch of people trying to shove that thing up the hill, you guys have heard of rolling the boulder uphill, rolling the stone uphill? In this case, we don't even have a nice clean stone. It's a blob of unknown origin. And we have all these people kind of holding us back in some cases. That's the nature of software development for most organizations. And of course, once you get through the first iteration, and the 9-month deployment cycle, the 12 months deployment cycle. You have to do that painful thing again and again and again, and that's why we don't do it that often. It sucks. Okay? But going forward, it needs to look more like this. That's why people are so excited about microservices, though many of us aren't doing microservices all that well. I had a nice conversation with some folks yesterday, like, I got 8 microservices. How do I do testing across them? Yeah, you got to think differently, okay, in this new world. But it should all be people pushing in the same direction with a nice structural integrity, right? A nice component that we know how to get up the hill there. If you haven't read Continuous Delivery, I'd highly encourage you to do so. And Jez Humble's test on things that are in trunk are ready for deployment, and everyone is checking in the trunk every day. These are critical tests to know that you're continuously integrating. If you're not doing these things, you're not continuously integrating, you're occasionally integrating. Just because you're using Jenkins does not mean you're really practicing CI. So think about that for a second. Everyone's like, I got Jenkins, we're doing CI. No, there's a practice and there's a tool. The tool does not give you the practice. It helps enable the practice, but you truly have to enable the practice this way. And a new developer on-ramps to one of your teams should be able to on-ramp and have their workstation ready in minutes, not days, or not even hours, minutes. Okay? And that's a critical aspect of making sure that you guys understand how to build the package that goes through, from development to QA to staging to production. All right? Here's the Fabric8 project. That's the URL for it. Fabric8, numeral 8.io. It has this cool robot. I have a little robot sticker here on my laptop also. But the idea behind Fabric8 is this is where we experiment to try really cool things, okay? So we focus on the concept of the act of creation. I'll show you an example of the wizard if we get far enough in the demos. But the idea is sometimes setting up a project is kind of hard, right? I don't know if you guys have to set up a brand new project. In some cases, it's the architect's job to set up a brand new project, get the CI system set up, configured correctly, get the Git repo configured correctly. Here's the default POM XML. Here's the default Jenkins file if you're going to do the continuous delivery through Jenkins. Well, we have a wizard that gives you all that for free, okay? We want to make it click, 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 POM XML, Jenkins file, Docker file if that's what's necessary, right? Everything ready for Git, ready to go. And all you do is pop it open into your favorite IDE, right? Whether it be Eclipse or IntelliJ or NetBeans or something of that nature, and you're ready to rock. That's kind of the idea. So that's actually a key part of what we focus on in Fabric8 is how to make the starting up process much easier. Also things like packaging. I'll show you an example of this. We have a Maven plugin that's super awesome for actually helping you build not just your jar file, your fat jar file you need to create, but the Docker image that wraps it and pushes it into Kubernetes for you. Okay, so you want to ramp, from a simple Java application to Docker to Kubernetes. It's Maven Fabric8 deploy. I'll show you that too. Okay, so we have a Maven plugin for that. Rolling upgrades across team environments. You get rolling upgrades for free with Kubernetes, but how do you do it across multiple teams? And how do you have visibility across teams doing these sorts of CI/CD activities? That's another aspect that we're exploring in Fabric8 is team-based development. You're going to see more on that as we go forward. Service runtime, scaling, failover, load balancing. A lot of this comes just in general microservices architecture. Kubernetes gives us some of this for free. Like for instance, service discovery is for free with Kubernetes. You don't have to have something like Eureka, but you could still use something like Netflix OSS Hystrix as an example. I love Hystrix in many of these cases. But the load balancing you also get for free too. Out of Kubernetes, management, centralizing logs, alerting, tracing, things like that. Feedback, how do you capture metrics, get it back to the team. And this thing just runs, I'm going to run it all on my laptop using something called Minishift, but you could run it anywhere, okay? It's just a bunch of software. And so a lot of, like if you saw Raphael's presentation, he was running it up at Amazon, just because that's the easiest place for him to run it, right? Let's keep going along here. Fabric8 is really based, if you will, focused on these three technologies, really focusing on making these things awesome, right? So Docker, Kubernetes, and Jenkins. So Docker. So you guys hopefully know all about Docker at this point. If not, wow, we've been talking about it pretty heavily now for a couple of years. But the idea behind Docker is super simple in my mind. You have this concept of the Docker file, and it codifies everything you need in your application stack. And there's no more ambiguity about what goes into your application as far as dependencies and prerequisites go. We have the POM XML to know exactly what our Maven dependencies are, but the operating system dependencies were via email, via wiki page if we got super cool. So in other words, how do we communicate as a developer to our operations team or QA team? How do you deploy my application? Right? Oh, it's a WAR file. Well, do you need WebSphere, WebLogic, Tomcat, JBoss? Well, I don't know. And what version do you need? What JDBC driver do you need? What data sources do you need configured? Well, the Docker file helps us codify those things. Now, here's one thing I'm going to show you in Fabric8. We can get rid of the Docker file entirely. So we'll show you that in a second, okay? But that's the magic of Docker. And of course, we could spend a lot of time talking about Docker, but let's assume you know some of that already. But it is super lightweight, easy to get started. I'll show you a demo of that real quickly. And actually, let's keep going, and I'll show you the demo as we get started. Now, if you have a Docker image and you have a Docker container, it's super easy to go Docker build, Docker run. But do you want to do Docker run, Docker run, Docker run, Docker run? Get on computer 1, Docker run, computer 2, Docker run, computer 3, Docker run. It's kind of hard to scale that way. It's awesome, but it's kind of hard to deal with that. And so there's different orchestration solutions that sit on top of Docker or around Docker, one of which is Kubernetes, and that's the one we're interested in at Red Hat. And so you can deal with things like how to scale, how to deal with port conflicts. I'm going to run everything on port 8080 on my laptop, everything. And it doesn't matter because Kubernetes takes care of that internally. Everything's running on 8080, but I don't have to worry about it, as an example. How to manage multiple hosts if we have multiple computers. And of course, what happens if a host dies? All this stuff happens in the context of Kubernetes, and that's really the magic we're going to talk about next. Okay? So Kubernetes stands for helmsman. It's the Greek word for helmsman. Helmsman meaning the person who steers the ship, because the Docker container ship, right? That's kind of the idea that container ship is the visualization behind Docker. Also, it includes this thing called a pod. And what is a pod? A pod is a Linux container. However, a pod is a family of whales. And the image, the image around Docker is a whale. So that's where the word pod comes from. You're probably thinking it came from that old sci-fi movie called Pods, Pod People? No. I had this question before, or P-pod? No, it's a family of whales is the idea. But this is, of course, inspired by what Google has done. And if Ray Singh was here from Google, he would tell you, Google launches 2 billion containers a week. We kind of know what we're doing around containers. I doubt anyone here needs to launch 2 billion. You might need to do 2 or 20 or 200, and this will still help you with that, okay? And you have lots of headroom to grow if you need to. So this is kind of what a Kubernetes looks like from a high-level standpoint. I'm trying to be mindful of the time. So you have the concept of master, and it has multiple nodes. Think of them as worker nodes or whatever you want to think of them. They're just other virtual machines or physical servers. And then, of course, you have an API layer here, etcd, which keeps up with, understanding it's the database, if you will, schedulers, controllers. And it's conceptually not that hard. We've seen these sorts of things before in cluster management, but the idea is that Kubernetes makes all this, gives you all these great primitives to work with. We'll show you some of those primitives in a second, but it's managing the environment and ensuring that all these little Docker containers are running happily, healthily. There's a healthiness probe or readiness probe, and if something is acting up or dying or injured, or something dies entirely, like a whole piece of hardware, it moves things around for you, okay? It takes care of rebalancing this environment for you. So there's these 3 components. I mentioned the pod concept already, but the idea is that it can hold 1 or more containers, and so that's actually something people don't know. You can actually have more than 1 container in a pod, and that's often if you have like a little sidecar pod, like here's the log aggregator, or here's the little, you'll see more about sidecars later in the year, but there's some really interesting sidecar technology out there coming now. And then, of course, you have the ability to deploy it and replication control it. So this is the guy to make sure from a deployment standpoint, if we need 2 or 4, we have several of those. We have the concept of a service. Think of that as the virtual IP address for those pods. And you can have multiple pods behind a service, so you get the load balancing for free, and you label everything, right? That's how you group things. You can say development versus production, or this is service A versus service B. You can do all kinds of interesting queries across labels, take down a group of pods via label, right? Let's wipe out the development version, put a new development version up. And so all these kind of capabilities, I'll show you some of this in the demo, is part of it. And we're not really here to give you a deep dive on Kubernetes today, but more give you an idea of what you could do with it and what kind of capabilities are available to you. So we got to keep moving though. Again, I mentioned the pod concept already. So the Docker image is this whale/container ship. Kubernetes is the helmsman, the pilot of the ship, right? Steers the ship. And of course, you have a family of these guys, a pod. So that's where the concept comes from. I imagine if someone here works for Docker Inc., they're not happy with what I just said. But that's kind of the nature of where these names came from. Okay? So Kubernetes by default gives you a self-healing environment. It ensures the environment stays up the way you ask it to, right? I want 3 versions of Tomcat up, 2 Mongos, 5 Postgres, 8 JBosses, 2 WebLogics, whatever it is you want. It ensures that environment stays up, okay? And it schedules and automatically restarts across the entire cluster. So this is kind of what it looks like when you add this OpenShift capabilities to it. So OpenShift is an instance, if you will, of Kubernetes. OpenShift is its own open source project, but it's where we actually take Kubernetes, add more value on top, experiment on top, and in many cases we take OpenShift ideas and push them back into Kubernetes directly. Okay, so that happens too. So you'll kind of see Fabric8 capabilities show up in OpenShift, and OpenShift capabilities show up in Kubernetes, and all this changes about every 3 months. So just keep that in mind. When you want to enter this universe, you pretty much have to be on it, because every 3 months things change dramatically. This is how fast these projects are all moving. They're getting better, so much vastly better, about every 3 months. You just have to factor that into the equation. But right here, you can kind of see OpenShift is identified as having a build or an image stream. So OpenShift wants to help you do your builds. It knows that you want to do builds at scale. I want to build farm. What happens if a base layer in the image, like let's say the Red Hat Enterprise Linux operating system, needs to be patched, or the JVM needs to be patched, and I have 400 container images with that JVM image? I can build farm that out and make sure those 400 images are all rebuilt properly, as an example. So that's the concept of builds and image streams. And so that's part of the developer experience and capabilities, things like that, are what OpenShift adds to the mix. Right? The build process is a good example of that. Okay, so you can see here in red where we've identified what OpenShift looks like as for add-on. I know you folks can't see too well, can you? No. You can come jump up and down over here now and then. But right here you can kind of see we focus on things like CI/CD, build automation, build streams. We also have the concept of an additional routing layer, and I'll show you an example of that. But deployment configs also, build configs, so that we know how things should be rebuilt when they need to be rebuilt. But otherwise, it's Kubernetes, okay? What happens when a certain node fails? It'll take those items and rebalance them, okay? And right here, you can kind of see if that node is gone, then these things show up over here, right? We need another Tomcat, we need another Mongo. It just moves around the cluster. All right, so let's actually show you the demo. That makes this much more interesting, okay? So let's do this. We're going to do some hacking over here. Let's start with just Docker, okay? So Docker images, my Vertex. All right, let's see if I have 2 versions of my Vertex out there right now. But actually, you can see I have lots of Docker images. Docker images, right? That's the image itself. I have lots of Docker processes, Docker containers running. This is all running again in a Kubernetes environment, kubectl, get pods, okay? kubectl get namespaces. Okay, and this is kind of the command line tools you use in a Docker world or a Kubernetes world. All right, so you can see I have a bunch of namespaces there, and so I can even do, I can drill down on all of these, but let's just show you the Docker piece right now. So this is a standard project, so Maven clean compile package. All right, and actually let's see if we can find, I think I opened the code earlier. Let's see here. So it's just this project right here that we're playing with right now. Okay, all it does is say hello Vertex in this case. It has a simple POM XML, nothing too extravagant in the POM XML, and it has a Docker file. And you can see we provide a Fabric8 base image. So again, Fabric8 looks to fill gaps where issues are found, and we found that there wasn't really a great JVM based image for Docker. As an example, that makes it super easy to get your microservice loaded into Docker. So we built a base image for that with Fabric8. You can see you basically identify your Java jar file right here. And then you basically determine whatever options you want for the JVM to start with, what port number. And all of this is pretty much standard Docker, if you're familiar with the Docker file. And then you're off and running. So if I come over here, and actually I'll just copy and paste this real quick. All right, let's do this. All right, we'll do our Docker build. All right, that Docker image has been created now, and I can just run it. Let's see here. All right, Docker run. And let me go to this, And let's see, do I have it? I might have had run it over here earlier. Let's see. Bonjour. There you go. Hello. That's the one we've been looking at. And so that's the Docker process. Docker build, Docker run, Docker build, Docker run. It's not super hard. If I want to come over here now and change it, let's go bring this down. Okay. Change the code. Let's call this, namaste. How about that? Did I spell it correctly? Or as close as I can as an American with my American keyboard. Okay, Maven clean compile package. All right, we're just going to recompile that Java code, and we're going to rerun the Docker build. We'll just overlay version 1 there, and we'll do our Docker run version 1. Go back into our browser, and if we did that, there we go. Okay, so that's the Docker process, and that's what makes Docker awesome. When you see that, you're like, holy crap, that's amazing. I just want to do Docker now all day, every day. And it is pretty awesome. But if you had to do this across many machines, it gets tiresome over time. So let's kind of play with that a little bit more. Okay, I'm going to come back over here and say, who am I? And let me see, I'm the admin right now, that's good. So I actually have a bunch of scripts here so I don't get confused and get out of sync because there's a lot of steps here. But now let's take that exact same Docker image that's been created and run on Kubernetes, okay? So I just have a bunch of scripts, so we can create the namespaces. I showed you that already, but this is what it runs. kubectl get namespaces. Some people call that kubectl. I call it kubectl. Maybe I have it all wrong. I can create a new namespace, okay? And so the kube demo namespace is now getting created. And so there it is, okay? And then I can create the Docker image. We've already created the Docker image, but let's go ahead and run that create again. So it did the Maven compile, did the Docker build, just like you saw earlier. Okay? And then let's do actually this, and I'll show you what this one looks like. Okay? We're going to create the pod. The pod is the wrapper with to pull it into Kubernetes. If we go over here, I'll show you what we're doing here. Okay? So it's a kubectl namespace kube demo, like you saw earlier. Create-f. So this is the common way you engage a Kubernetes environment. Create-f and some YAML file. And there's all the different properties within Kubernetes you set. What I have here inside this YAML file is this guy right here, myvertx, and then we have a readiness probe on it also. So you can specify a liveness probe and a readiness probe. You should do them in pairs. I just was lazy here. But with the readiness probe, that means Kubernetes is constantly monitoring that thing to see if it's alive and well and ready to accept traffic. That's probably the key aspect of it. Is it ready to send traffic to it from a routing standpoint? And so if I come over here and say kubectl get pods, okay, I got to get into the right, let's get into the right project. I'm going to use this switch project, so it's kube demo, right? Yeah, kubectl get pods. And all right, so there's my vertx running right there. Let's see here. Okay, yeah, let's do this. So we created it. Let's expose the service. By default, any pod that you start is internal, has an internal IP address. It's not exposed to the world, so we expose it. You can see what that's exposed deployment, what port do I want to expose it on, and give me the load balancer. Like I said, there's a software load balancer built in here for free. And then I can do things like curl it. I have this curl command here, so there it is. So we're curling that namaste Docker image I created earlier. So we can do that, and actually let me just switch windows here while that's running. Okay, let's see, who am I? All right, make sure I'm the same person here. All right, and back up. And let's do this, let's scale it up. So this is where we basically say I want three of those guys in production. That's replicas equal 3. And if it works out okay here, there you can tell right here, that's the host name that application thinks it's running on. And you can see it's round robin load balancing now across all 3. And just to kind of give you a feel for another visual of this is the OpenShift web console that sits on top. And come on. Oh, okay, this is great. What it's doing to me is basically saying, I think in mobile mode. I don't want to be in mobile mode. Responsive design. Right here is kube demo. There's the 3 pods we're talking about. If I drill down on it, there's again the host names, or basically the pod names, the container name for that. And you can see that we have 3 of them. Okay, it's kind of the idea. And that's what's going on here with my curl. It's just curling across all of them and displaying them. It's just, interacting with it. That's basically it. Okay? So that's kind of the idea behind Kubernetes. Those sorts of things are super easy. But let me see if I can, let me actually go change the code one more time. Let's see if this works for me. And we'll go here, and we'll go here. And let's just go to bonjour. And then let's see if I did that correctly. Oh, it does the Docker. I forgot to do the Maven build. So let's cancel that. Vertex, okay, Maven package, or clean compile package, just be on the safe side. All right. And if we did our job right here, let's see, notice it's creating version 2. Okay, it's building version 2 of that, so Docker images. Helps if you type correctly. Grep, my Vertex. All right, so we have version 1 and version 2. Version 2 is 11 seconds ago. It's kind of the idea. And now we do this. We roll the update out. If we did that correctly, okay, so basically it's just this command, kubectl, kubectl, namespace, set image, and I'm changing the underlying image, and you can kind of see now it's gone to bonjour. Okay? And I guess I could have pulled up the OpenShift console. You would actually see it visually happening there. But I basically said take all 3 of your previous containers. There were Namaste, version 1, make them bonjour. And you can decide if that's not what you want, okay? You can undo that. You can roll it back. And you can basically go backward to the previous version that we had. And actually, let's see. Oh, there's the animation happening. You see it scaling. And then we're back to Namaste. So this is the power of Kubernetes and Docker. And again, I'm hoping that most of this is kind of stuff you guys have seen or heard before, because we want to dig deeper than this. But this is kind of where the baseline is from our perspective to do things like OpenShift capabilities and Fabric8 on top of that. Is that cool so far? Okay. All right, we only have about 30 minutes left. Oh, look, we're doing okay on time. Fantastic. Let's see, what else do we have here? I think that's all I want to show you from a pure Kubernetes standpoint. But, again, kubectl is your friend. And one thing I'll show you here, this is Minishift right here, running right here. One more directory back. There we go. And so the Minishift technology is basically giving us, it's like Minikube, by the way. I don't know if you guys seen Minikube before. It's an instance on your local laptop. I have it running here in VirtualBox, right there. So that's what I'm using. So I'm also dedicating a lot of memory to it, 7 gigs of RAM, because there's more stuff coming. So there's a lot of stuff happening in here. So just keep that in mind, okay? Now let's kind of jump back into slide mode. Let's talk quickly about some other capabilities, like Jenkins, and then I'll show you some more Fabric8 capabilities. Are we good so far? Am I talking way too fast? You can say yes. It's okay. Okay? Now, everybody uses Jenkins on a regular basis, it feels like. Some of you don't use Jenkins, use something else like it, but most people have some form of continuous integration build server, and they continuously integrate every now and then. In other words, it's not very continuous. It's eventually continuous, that kind of thing, because what happens is you guys use a lot of feature branches, right? And if you're using a feature branch, you're not continuously integrating. Some developer or a group of developers is on a feature branch, let's say for 2 weeks or 3 weeks, then they come back to try to integrate back to trunk, and they suffer lots of pain accordingly because other things have changed in trunk since they left and went off in their feature branch. So one thing you have to consider is, are feature branches good or not good? And some people would say not good. And I'll tell you one example of not good, because I was talking to another very large financial services company about this topic. They said, Burr, you don't understand. Yeah, we have long-running feature branches, sometimes months at a time, and our integration opportunities or integration chances are really horrible, right? Here's what's better. Because their systems are so broken from an internal DevOps kind of process standpoint, they actually have developers with different series of services, all on their own different feature branches. Then when eventually trunk does get built and they think it works well enough to pass unit test, it goes to QA, and they patch and feature branch in QA, okay? And then they push it to staging, which has its own feature branches and patches, and production even has feature branches and patches. They honestly never know what the real source is in their system? No one knows. It's just so, because it's been changed so often along the pipeline, they have no idea what the other end is. So the concept of all this Docker stuff we're talking about and Kubernetes stuff is so you can have the immutable image go from the very beginning of development. The developer knows exactly what's in the payload of that image, and it goes all the way through QA, and everyone tests it where they know exactly the operating system, the configuration, the Java payload, we know what it is. It goes into staging, we know what it is. It goes into production, we know what it is. Therefore, if we have to fix a bug, we know exactly what the source of truth is for that image that gets out there. So the concept of the deployment pipeline, which is what we're going to talk about next, is to prove that the release candidate is unreleasable. Now this is backwards from how most of us think of it. We think of that pipeline, which in many cases the pipeline is nothing more than a PowerPoint slide for many of us, or a whiteboard diagram where someone said, well, I think these are the steps we go through to go from development to QA to staging to production. Right? Someone hopefully drew that in a PowerPoint slide. Some architect drew it on the PowerPoint slide. Some manager has it on the whiteboard. But in this case, we're talking about automating it and codifying it, programming it. It's programmable pipeline. And the whole purpose of a programmable pipeline is to ensure that the thing that was checked into trunk and is moving by default towards production in a continuous delivery way is unreleasable. Because by default, we assume our quality is so high it's always releasable. So a default assumption. So fundamentally different from how we think historically, right? But the QA team is to see if it's releasable or not. No. We do enough automation up front that we know it's releasable, and this catches bad things. Okay? That's kind of the idea. So if you use Jenkins for continuous delivery, it involves this thing called a Jenkins file. I'll show you an example of that. And the Groovy DSL is just a Groovy script at the end of the day. And you basically put stages in there, and you run and execute things inside those different stages. It's actually not hard. And it's just a simple Groovy script at the end of the day that you can check in to your source code repository with your microservice. So inside your actual source repository is probably not only a POM XML and Java code, but also a Docker file potentially and a Jenkins file potentially. And I'll show you that as an example in a second. So it's just a Jenkins file. Now one of the things we're doing at Fabric8 is we provide tons of Jenkins file templates to kind of give you some ideas as to things you can do. We also give you a ton of Kubernetes templates. And actually, let me pop that open real quick just to make that point a little bit more crisply while we're here. Let's see if our, whoa, didn't mean to do that. Let's see if our internet connection is still up. Okay, so this is the Fabric8 project we talked about earlier. Let's just jump over here, Kubernetes manifest. Okay, these are things we want to help you deploy to Kubernetes. All right, API management. There's brackets, camel stuff, Cassandra. There's Chaos Monkey, and actually the Chaos Monkey is super fun. It's like the Chaos Monkey from Netflix. The idea is it randomly kills things in the infrastructure so you can see if your software is really resilient. It's kind of fun. There's chat bots, so if you want to have chat ops with the infrastructure, so when it's doing a continuous delivery build, it can chat with the development team and you can see the build processes. There's an Eclipse Che thing here. You can see there's just tons of stuff. AWS, right? Braintree, what else do we have here? The list goes on and on and on and on. You want to integrate with Slack. I mean, it's a very long list. And now, here's the challenge. You're probably thinking, how in the world do you guys QA all that? This is why we need your help. So this is how you can get involved with the Fabric8 project and help us make sure these things stay up to date and are always working. There's over 200 and something projects in the Fabric8 repository, or 200 something repositories in the Fabric8 organization, and we practice CI/CD across all those too. Okay, so all of these 200 plus repositories are being built on a continuous basis and pushed through the system and being deployed out, so that you're grabbing the right artifact. And sometimes things do go wrong. But this is exactly how we're trying to experiment with all this. If we're going to preach continuous delivery, we're going to practice continuous delivery as an example. So Elasticsearch, the Fabric8 console, there's a Fabric8 Forge. I'll show you a bit of that, but we have a different version of it too. And Function, a serverless architecture. So if you're interested in serverless, Amazon Lambda, it's called Function. Garrett, code reviews, GitLab, GOGs. You want your on-premise GitHub kind of thing. I mean, it just goes on and on and on. So please get out there and try some of these things. Tell us where it's broken. Help us make it better. I can tell you, I'm not an expert in Kafka. Maybe you are. maybe you can help us make sure this is the right template for getting it kickstarted properly on Kubernetes. You would know better than me. So, no one human knows all these things. This is why we need a community to make it all work. Kibana, Keycloak. If you've not seen Keycloak, it's awesome. SSO as a service kind of thing. Just check that one out. Obviously Camel. People on this project. James Strachan, he was the creator of Apache Camel, so we have you'll see a lot of Camel stuff in here. We have lots of awesome stuff. As I mentioned earlier, we do have a getting started document, and I'll tell you it's broken. Okay, so just watch out for that one. So it is a little bit tricky. We basically tell you, install Minishift and then run Fabric8 on top of that. It doesn't work at this moment. Just keep that in mind. We're going to work on that, but it's going to take us a couple more weeks to get that right. Okay, but there's also some great videos and some other aspects of this. Okay, but let's kind of give you a demo of this. That'd be the best way to do it. Okay, so let's go back over here. We did the Vertex demo, okay? We did that one. And let's show you this example. Let me find the right directory. Kube for Docker. By the way, all this is out on my GitHub. This demo environment with all these scripts and stuff are out there on my GitHub. But Vertex demo, no Docker file. Okay, we're gonna show you this one. So one of the things we've done in the land of OpenShift that's kind of over and above Kubernetes is I'm going to show you this little aspect right here. Okay, let's look at my README. Oh, this is the wrong one. We don't show you the Fabric8 one just yet. We're going to show you this one. Okay, this one right here involves something called S2I, source to image. The whole idea is, if you notice carefully, there's no Docker file in this directory. So we're trying to eliminate artifacts that we believe you don't necessarily have to have. For instance, if there's a POM XML, we can assume you want a Maven-based build. Probably a good assumption. And we can assume you want a Java base image to run that on. So we make some interesting assumptions, and that's called S2I. So let me run this real quick. Right there. And actually, let me go and log in as developer. So I was admin. Let me log in as developer. Okay. Oh, I put the project in the wrong directory. OC delete, or under the wrong person. S2I demo. And developer can't delete it. Okay, never mind that. Here's what we're going to do. Let's do this. We'll just make a different one. Okay, so we're in this project now. That's a namespace in Kubernetes. Let me go back. I can go to my console real quick, and I would go here. There it is. This is the one I'm going to focus on. Okay, there we go. Right here. And there's not much going on with it, but watch what happens here. Let's see if this works for us. I'm going to say OC new app, and actually before we do that, Maven clean compile package. Make sure we're all packaged up, right? This actually builds a jar file. There we go. It builds our fat jar. So if I look here, right, there's the fat jar. And if we look at the size of that, just so you know, I mean, this is all this microservice-y stuff, right? It's not very big. You can see it's, a relatively small guy there. And what I'm going to do now is I'm going to use this thing OC new app, and it's going to be creating that guy for me. This will take a little time, but you can see it's getting created right now. Okay, and so basically what happened is, even there's no Docker file, it's doing a Docker build for me. So we eliminated a step. We eliminated a piece of the architecture there, and that's really what this guy is for, is to do that sort of thing. So I can say OC logs -f bc kube for Docker. Okay. You can see it's doing the Maven build, right? Because it's actually taking the source, original sources, and then it's going to do the Docker build. So that way, and the reason we do this is so you know you're getting an exact build of the immutable image and with the right operating system, exactly the way you want it patched, configured, etc. Okay, so you know exactly that this is the thing that should land in production. That's the whole idea behind it. If you do the Docker file, the developer might mess up the Docker file a little bit, have the wrong version of things in there. And the operations people are now like, what? What operating system did you pick? That's not what we run in operations and production here. So the S2I helps ease that process, right? It basically says, you can define what your base image will be, and everybody agrees that that's the base image. It's kind of the idea. So it's going through its process there, and that's what that's for, okay? But it's going to take a while to run based on our network, but we don't have to mess around with that. Well, let's go check this out over here. Let's see here, okay? Let me show you another example where this gets a little bit more interesting. Here's the same project, if you will, but there's going to be a major distinction. Okay, this one says Bonjour also, and it has the POM XML. But the difference here is we have the Fabric8 Maven plugin in this one. That's the real distinction. So we're going to eliminate even more steps. So in this case, we know exactly how to build this next project. So let's build a new OC new project. Okay, and let's see here. Let's go ahead and know who I am. Okay, good. New project. And then Maven Fabric8 deploy. That's all I do. Okay, so there's no Docker file like in the previous step, but in this case, there's none of these other steps either. So we again try to eliminate more and more of these ideas as we go. So here it is. It's good. We're going to have the same result that you saw earlier. Okay, same result you saw earlier, but several steps have been eliminated. Let's see, is it already up for me? Let's see, I don't know. I probably don't have a readiness probe there, so it's not yet up. But that is kind of the idea with the Fabric8 Maven plugin. If you're a Maven-based developer, now it fits directly into your workflow. You know, you don't have to think in terms, oh, is my Docker file right? Is everything else right? You can just say Maven Fabric8 deploy, and it deploys to your local cloud environment or remote cloud environment. Primarily we focus on the local cloud environment, like you see here with Minishift. So that's kind of another aspect of where we're trying to improve the developer experience around all these technologies with the Fabric8 project. Okay, let's see here. This guy is, okay, so this guy is still running in the background, pushing the Docker image now. Okay, and so I'm actually technically running 2 deploys simultaneously at this moment. Let's see, did that one come up yet? Yep, there, okay, so that's the one we just did, the Fabric8 one. And let's go back over here. And this one right here, bump, bump. Click the right button, oh, click the right button. Did this one come up? Okay, yeah, so that pod's up now. So in order to finish that piece of the process, if I go back here, there's actually a few more steps on that one that we had to complete. Okay, we had to get services. There's our service that was created, and we have to expose it like you saw earlier. All right, and oh, what did we call that service? Oh, oh, I'm in the wrong project. Hold on. Yeah, project S2I demo 2. There we go. Get services, expose service. You're not normally supposed to do this back and forth, but you know this is what I'm doing at this point to make it go faster. Okay, and if I go back to my user interface, let's see here. Is this guy up? All right, so that's that one. So I've now redeployed this thing multiple times, just in the short session that we had so far, but I've showed you different ways to get your Docker image created, deployed into Kubernetes, into the same Kubernetes instance in this case, but using the S2I environment or using the Fabric8 Maven plugin. So again, just simple examples where we're trying to always improve this process. Now, let's get in here and do something a little bit more interesting. I want to show you this guy right here. Let's see if this will work for me. I'm running something called Launchpad, all right? And if this works, it'll be awesome. If it doesn't, it won't be awesome. But this is something brand spanking new that we are working with. We're technically giving this to the world next week. So you guys are getting a sneak preview of what we're talking about. And we call it Launchpad. And the idea, as I mentioned earlier, is the concept of a wizard. Can you make things more wizard-driven and get started? So if I come over here and hit next, I'm going to actually say, okay, I want to build a health check-based project. And we'll just pick health check for now. I can pick from one of these 3, and actually Fabric8 has many more than just these 3, but we're focusing right now on just these 3 from a getting it ready for a support standpoint. I want to build a new Spring Boot project, I want to build a new Vertex project, or a Wildfly Swarm project. And you can pick, you know, I'm going to just say boot, and I'm going to just say boot, and I'm going to call this boot 6, so I have a clean project, you know, a new project. I'm going to hit next, I'm going to say launch on OpenShift, and now watch what happens kind of carefully here. And my system is pretty overwhelmed, so this might actually take a moment. And again, the network's kind of slow. But we're going to go through the process now of actually building that project, not only locally running in my local Minishift, but it also sets up a GitHub repo. Okay, so and actually what we'll do here is the run I just ran earlier. See, my boot 5. It basically gives us a default project with a default Jenkins XML and a default POM XML. So that's a Jenkins file, and the POM XML includes the Fabric8 Maven repo that we saw earlier. Fabric. So that same Maven plugin is in use now, but you don't even have to add it to your POM XML. We add it for you. So again, we're further trying to automate things and take steps away so it makes it easier for you guys to work with. And let's see, is this guy, where's my other screen? Huh, too many screens. Okay, uh-oh. And I got a runtime exception trying to connect to GitHub in that case. So in this case, it couldn't get connected to GitHub, but this is the kind of project it would create with a POM XML, and like I said, a Jenkins file. And then once that thing is created, you will have a local instance of it. Let's look over here. Here's my boot 5, the one that I just created when I ran the wizard earlier. It gives me a Jenkins server automatically. Okay, there's the project, simple project. Will it get connected for me? And I'm definitely having network issues now. Let's see. All right, there we go. And I can say this, call this Burr, invoke. So it's a simple project, but it basically sets up the whole environment, you know, everything you saw earlier, plus I now get for free this thing called a pipeline. Okay? And you can see the pipeline had run earlier, and I can start the pipeline again. So it gives me, in this case now, the GitHub repo with the POM XML, the Jenkins file, all built and configured so it runs nicely here in this OpenShift environment, this Kubernetes backbone, and now I can just start my pipelines. Yes, sir? S2I? It actually does do STI underneath the covers. Yes. Yeah, so if you look at the Jenkins file, where'd it go? This one. Okay. This is a super simple one. Thank you, sir. Okay. You can see it just check out the SCM, run Maven test, deploy. So we did the Fabric8 deploy earlier, okay? But now you can kind of see we've kind of further automated it, and you run it through a pipeline. So hopefully this makes sense, and I showed it the way I wanted to show you these steps, right? You can start just Docker build, Docker run, right? kubectl and do the things there and all the steps involved. Then S2I eliminates several of those steps. Then the Fabric8 deploy eliminates several of those steps. And then with the wizard, we eliminate all the steps. That's what we've been doing in this Fabric8 land, okay? As an example. And so there's more to show you here. Let me find a better example of a pipeline. I think I have one here. It's one of those things where you keep hacking on your environment. Let's see, is this my more interesting pipeline? No, I don't have the more interesting pipeline. But you can actually, depending on how you set up your Jenkins file, you can actually have it part of the build config, which is part of the Kubernetes metadata, and that's what this one is. That means I can inline edit it right here. Or you can have the actual Jenkins file in the GitHub repo. And so you can add stages. Let's see here. That's doing the build. I'm going to add a stage. Okay? Let's call this the inspection stage. You know, you do whatever stage you want, and then you basically can put in a sleep to kind of, in this case, let's just illustrate like work. I can put an echo, but you script, you know, bash shell scripts, go crazy. It's just whatever you need to do. Just keep in mind it's running on a Jenkins slave, right? And therefore, the Jenkins slave has to have whatever you want in it. So if you're going to do a Maven compile, you need to have Maven there. Just simple things like that. Out of the box, you can see this one's a Node.js one. We do have those profiles set for Node.js, Maven, things like that. Inspection phase, and if I want to add another stage, let's call this the testing stage, right? And I'm just putting sleeps in to kind of simulate work. But if I did that correctly, all right, save it, start the pipeline up, and this will take a little time, but you can see it going through its process. And if I do the view log, okay, basically it pops me into Jenkins. All right, confirm the security exception, log in with OpenShift. Yeah, I think I'm developer in this case. This is what happens when you switch systems too often. You can't remember who you are. Log in with OpenShift. Come on. Maybe it's admin. All right. Yes. Waiting. It's waiting. Oh, man. I think I'm actually having another network issue. Come on. There we go. So basically I had to do the redirect and get me in. But you can see it's going through the process. It's literally going out to GitHub right now. And clone is trying to do the git clone. So it's a little slow across the network. But it's doing a git clone to that project, doing the build, and doing those stages that you just saw me play with there. OK? So we'll let, and it's timing out, waiting on Git again. So obviously I have to work on that from a Git standpoint. But let's kind of jump back into slide mode, make sure we cover all the right ground, because we're running out of time. Okay? But really what I want you guys to do is think in terms I have one of those put your tab to sleep tricks, and that's just what happened here. Saving memory in Chrome kind of thing. Okay, so the Jenkins file is just something like this. You specify your node, you specify your stages, and typically you have some sort of validate stage, testing stage, build stage, deploy stage. You could even have it create all new Kubernetes namespaces, OpenShift projects, like dev, QA, stage, production, and deploy to all of those. I have examples of that too. And you can get creative here. Like here's one that was actually a fair bit more work. Log in with special credentials to a special server, run very specific commands. It's just a shell script. It's just a groovy file, right? So go crazy with it. And what else we have here? Other examples. So these are other Jenkins file examples. And actually, let's see if this will load for me. I'm curious. If I can get GitHub. Okay, so this is going to respond. But like here's another example. The reason I call this example out is this is actually our demo that we showed. We showed it last night, but we call it Hello World MSA for microservice architecture. It's at bit.ly MSA instructions. It walks you through how to configure and set up a bunch of microservices, do blue-green deployments, canary deployments, right? And set up a Jenkins file in the old way of doing it before the wizard was around, okay? And that's why that's here. But you'll see things like how to use Kubernetes config maps, how to use an SSO server. So there's config maps, which basically are environment variables, blue-green deployments, canary deployments. All that's part of what this example is. This is what we showed last night at the Docker meetup. I'd encourage you to check that out. And one of the things is this Jenkins file as a good example. Okay? What else do we have here? Okay, we won't spend much time. We only have 5 minutes left. But just a couple other things to be aware of. Personally, I'm a big fan of the canary deployment. Blue-green is super cool, right? Blue or green, deploy left or right, and fail over back and forth is super nice. You saw earlier in the Kubernetes demo, we could deploy and then roll it all back very easily. That's the kind of magic you get in this world. But the one thing I like about the the canary deployment is I can deploy one little pod, let's say one little container, and send just a fraction of traffic to it, real production traffic to it, and know if it's going to be successful. I can know if its CPU is going to go crazy, it's going to log out a bunch of errors, memory is going to get all messed up, right? Something might go wrong, and I can roll that small thing back out. The idea of the canary is you just put one little thing in production, and it's just one little bit of use by your users, and you can take it back. And so that's the idea of the canary deployment. I'd encourage you to be thinking about the canary deployment. I fundamentally believe this is the way we want to deploy everything going forward. And one of the things you'll see if you get a chance to run some of the Fabric8 wizards and things like that, in this example I just showed you, we offer one pipeline template. And a new version, you're going to see 2 or 3 or 4 pipeline templates, one of which is always a canary rollout of the end. And then, of course, with a human approval step. So I'm the production owner. I can say, yes, go. It always does the canary. And if the canary dies, it automatically rolls back. That's one of the templates that we've been working on. And you'll see that in different examples and in the documentation. I don't have that one running right now, so otherwise I'd show it to you. Okay? So that's part of it. I guess that's all my slides. Let me think. Did I kind of walk you through everything? I kind of had to cover a lot of ground in a hurry because we're nearly out of time. But are there any specific questions that you might have? Any thoughts, things like that? Do you have a Gradle plugin? I don't know if we have a Gradle plugin. I always use Maven. Let's see, Gradle, Fabric8 plugin. We might. And if not, you could certainly contribute one. Looks like somebody's working on one. Okay? That's not one of our people, though. So, yes. But feel free to check that one out. And seriously, we're looking for people to come work with us on this effort and try these same things. So if what you saw here excites you, and you want to live in this Linux container Docker world, and you want to have an automated deployment pipeline with Kubernetes, we want you to come and get involved with this. And like I said, it's one of the projects you can get into relatively easily because of the nature of the project. Other questions? Does that answer your question, by the way? Close enough, at least. Yes, sir. Base image, yes. No. No, in this case, I think that Fabric8 one was sent to us because it's out there at Docker Hub. Okay, we do have production from a Red Hat standpoint. you can get production images also, which comes out of a different registry. I think it is called access redhat.com/containers. If I might have the URL correctly. This is our Docker Hub, and this is where you get things like you get more Atomic-based images as well as Red Hat Enterprise Linux-based images. Okay, but by default, I think the Fabric8 one is CentOS. That's kind of how we, in the community side, we tend to default to CentOS. We could go look, but I, haven't looked in a while. Yes, sir.
I have two questions. Firstly, how does Kubernetes compare to Docker Swarm?
Mm-hmm.
The second one was, is the OpenShift using any underlying software-defined network like Fanon or Weave?
Okay, so software-defined networking, and as well as Docker Swarm versus Kubernetes. That's the two questions. So I'm not that well versed in Docker Swarm. At least I haven't looked at it in over a year. When Red Hat made a commitment to go to the Kubernetes route a couple years ago, I kind of started ignoring the Docker Swarm world, and it's actually now called Docker Swarm Mode, and part of Docker EE. And of course, the names have changed a lot over the last couple of years, including recently, like with Moby. So I honestly can't say what the delta is at this point. The last time I saw a demo of it, they looked very much similar, right? It was like everybody's kind of copying each other. It's a good shootout. On the SDN part, there is an SDN built into the OpenShift. So OpenShift adds that on top. That's where the routing layer comes from and allows you to do really interesting fine-grained manipulation of the network. So that's definitely part of it. Oh, we have 1 minute left. Yes, sir. Yeah.
Does it expect the pre-deployed, pre-configured slave configuration, or does it use the host to actually use?
That's a very good question, and I'd have to go look to see exactly what slaves it is using. But you'll notice that we did deploy our own Jenkins here. So this is a template we've provided, so Jenkins configured the way we want it. Right? So. In this case, with the wizard, as it stands right now, you get a Jenkins per project. I've asked the team to work on that so I can have a universal Jenkins across all my projects. But this is just the way the wizard works as of this moment. Yeah, we're working on that, though. That was one I thought was good, too. Thank you guys so much for your time. Do check this out online. Follow me on Twitter. Hit me up on email, burr@redhat.com. I'd love to hear more of your feedback. And if you'd like to get involved, you can see this gentleman right here. He's on our core team, specifically working on some of these elements here in Bangalore, because we have a huge engineering team here in Bangalore working on some of these projects now. Okay, thank you.